Good morning, everyone. My name is Luis Guerrero. I'm the Country Chief Executive for Bureau Veritas in Spain and Portugal. I'm a naval architect with a PhD degree from the University of Madrid. I'm going to speak about regulatory aspects of the marine industry, more in detail about Annex 6 to Mark 4. Well, the emissions from ships, air emissions from ships, air pollution from ships are in this table. You can see that CO2 is an important part, but the most important contribution of the marine emissions to air pollution worldwide comes from NOx and SOx. We will talk a little bit about that later, but we have to focus on this contribution because in percentage it's much bigger than CO2 or particulate matters. For this purpose, MARPOL is the International Convention for Air Pollution Prevention. In its Annex 6, provides regulatory measures for the prevention of air pollution from ships. You know that MARPOL is a convention that has other annexes. Number 1 is for oily charges from ships. Annex number 2 is for dangerous goods. Number 3 shows towards the waters and so on. Now we are going to concentrate our presentation about Annex 6. It means air pollution. Annex 6 is in force since May 2005. It applies to ships over 400 gross tonnage and also to offshore units built after 2005. The compliance of the ship with Annex 6 to MARPOL will be marked by the issuance of an IAPP certificate, International Air Pollution Prevention Certificate. As I told you, Annex 6 was adopted in 1997, but it only entered into force 8 years later. You know, there's a ratification process, and it took 8 years to ratify and to enter into force. Its purpose, as I said, is to limit shipboard air pollution, ozone depleting substances, shipboard incineration, SOx, NOx, particulate matter, and volatile oil compounds. Annex 6 certificates are an IAPP and also EIAPP. IAPP is for the ship, air pollution prevention, and EIAPP is for the engine. As we will show later on, each engine has to be provided with a certificate to state that the engine, the emissions, NOx emissions, are within limits. The annexes was revised, and the amendment for the NOx and SOx entered into force in July 2010 with the strengthened emission limits within ECA. Within ECA are emission control areas. MARPOL Annex 6 covers ozone depleting substances, nitrogen oxide emissions from diesel engines, what we call NOx, sulfur oxide emissions from ships, what we call SOx, volatile organic compound emissions from tankers, shipboard incineration, and fuel oil quality. Also, depleting substances are prohibited on all ships. They are defined in the Montreal Protocol on substances that deplete the ozone layer. And the following ODS may be found on board ships, mainly in firefighting or even in refrigerating units, for air conditioning or for treatment, refrigeration for treatment plants. Deliberate emission of ODS during operation, maintenance, repair, and so on are prohibited. Hydrofluorocarbons are permitted until January 2010. For diesel engines, NOx are limited. It applies, this Annex 6 applies to diesel engines with a power over 130 kilowatts, and it doesn't apply to the following engines: emergency diesel engines, engines installed in light boats, other engines used only in case of emergency. For shipboard incineration, Annex 6 requires incinerators installed on board a ship after January 2010 are to be type approved in accordance with some requirements in the rules, in the convention. Operating manual. There has to be an operating manual specifying how to operate the incinerator in order to facilitate the crew to use the incinerator and to prevent from air pollution. Incineration of certain substances is prohibited, such as cargo residues, PCBs, and so on. Personnel responsible for the operation is to be trained. Regarding fuel oil quality, the appropriate authorities will have to maintain and register a local fuel oil suppliers list. Details of fuel oils used on board shall be recorded by means of a bunker delivery note containing the following information: ship name, IMO number, port, and so on. But the most important thing is the density at 15 degrees Celsius and the sulfur content, because the important thing for annexes is the sulfur content. There has to be a declaration signed and certified by the fuel oil supplier representative that the fuel oil supplied is in conformity with Regulation 14 related to sulfur content and Regulation 18. You know that most fuels used in the marine industry are blended, so that is why it's important the certification from the supplier, because only the supplier knows the composition of the blend and the sulfur content. Bunker delivery notes are to be kept on board until on board the ship for a period of 3 years after the fuel oil has been delivered on board, in order to prove the sulfur content. The bunker delivery note shall be accompanied by a representative sample of the fuel oil delivered, in order to make a counter-analysis if necessary. The sample is to be kept on board until the fuel oil is substantially consumed, but in any case for at least 12 months from the time of delivery. Guidelines for the sampling are in this resolution that I mentioned, just for your information. Not necessary to know it. Well, NOx. NOx means both NO, nitrogen and oxygen, and NO2, which are formed during fuel combustion in the inside the cylinders of the diesel engines, of the internal combustion engines, not only diesel engines. Only emissions from diesel engines are considered in Annex 6. NOx emissions from marine diesel engines account for approximately 17% of global MOx emissions produced by fuel combustion. That is why the maritime industry is aware that we had, in fact, to do something to reduce our share in the global NOx emission. And the Annex 6 is the answer to this requirement. Other sources are considerably lower. That is why they are not considered. And we consider only diesel engines, or emissions from diesel engines. For instance, if you compare it with boilers, only 2 grams per kilowatt hour and 5 grams per kilowatt hour for gas turbines, compared to 10 to 15 diesel engines. Why? Because the temperatures and pressures achieved inside the cylinders are very high. I will show you later on a picture. It's more graphic. NOx has harmful effects on the environment, acidification, formation of ozone, adverse health effects. That is why we have to reduce them. The NOx emissions are influenced by the combustion process. It means that the NOx emissions depend on the technology of the engine. When the combustion temperature and duration increase, the amount of NOx formed increases too. Higher peak pressure and compression ratio result in higher NOx emission levels. NOx influencing parameters include injection parameters, timing, nozzle, pump, fuel cam, injection pressure for common systems, and so on. Combustion chamber, cylinder head, piston, cylinder liner, compression ratio, valve timing, and charge air system, turbochargers, charge air cooler. Equipment to reduce NOx emissions maybe there are several solutions. Direct water injection, charges humidification, emulsified fuel water emulsion, exhaust gas recirculation, selective catalytic reduction, injection of urea solution. There are several ways. Only SCR is complying with GR3 that I will show you later. But the purpose of all these methods is to reduce the temperature and the pressure inside the combustion chamber, in the cylinders of the engines. Well, as a consequence of the Annex 6, some emission control areas have been established. You can see in the map there is an SOX. The emission control areas may be for SOX or for NOx or for both, or even for particulates. In the North Sea and the Baltic Sea, there is an emission control area for sulfur. It's called SECA. And in the coast of North America, and countries attached, Puerto Rico and islands and so on, Hawaii. And NOx and SOx in particulate material emission control area. Well, the important thing is to, well, this the timeline of the entry into force of the limitation in SOx. The important thing is, well, we are now in 2015, and you can see that we come from a period before 2010 where the sulfur content in fuel was above 4.5%. Now, in open seas, we can only burn in the diesel engines, in fact, fuels with less than 1% within a sulfur emission control area. It means that we have divided by 4 the emissions, and it's a huge improvement that we have to be satisfied of the responsiveness of our industry to achieve this very important challenge to reduce, but from 4 to 1%. But not only that, that even imports in EU ports and in sulfur emission control areas, the maximum allowed is 0.1%. It means to divide by, to reduce drastically. We have reduced drastically, and it is we can be satisfied with this achievement. Excuse me a moment. Okay. Well, it's not easy to reduce the SOx emission because for SOx you have to wait to reduce either the content of the sulfur content in the fuel tanks is the one provided by the supplier, by the bunker supplier. So, and the sulfur existing in the tanks, in the fuel tanks, will go out from us in the exhaust gas. So you have to wait either to reduce the pollution from sulfur caused by sulfur, either to use low sulfur fuels or to clean the air exhaust. But if you want to clean the low sulfur fuels are more expensive, and but cleaning of exhaust gases requires additional equipment, such as this one displayed in the picture, whereby you use some components, and you will recover also a sludge or residue. So you have two solutions, either to reduce the sulfur in the fuel using marine gas oil or similar, to clean the exhaust gas with screws that will take a residue in consequence, and the residue caused by the treatment of the soda, the sodium hydroxide, or to use fuel that is new for insect. Is very well known in the marine propulsion, but is new in some segments of the propulsion. It is a liquefied natural gas. We will talk later on about this liquefied natural gas as a fuel for ships, but it's a very good solution. One of them. Regarding NOx emissions, well, there was a timeline in order to reduce the NOx emissions, and I want to show you the evolution. This frame is more visual. There were 3 steps. The last one beginning January next year, so it's around the corner, and it is depends on the ship keel laydown. As I told you, the Tier 3 step begins on the 1st of January next year. And the important thing, and it's another satisfaction from that we have in our industry, that we have in our industry, the engine manufacturers have been able to provide the marine industry with new developments that have been able to reduce the NOx emissions 80%, by 80%. That is too much. We have to be proud of it and to recognize it. So, as I told you, the solutions for emission reduction is the main solutions are either exhaust gas recirculation, that is not compliant with Tier 3 so far, the selective catalytic reduction, SCR, that uses ammonia, needs some additional equipment to use ammonia. Another solution is the use of LNG as fuel, that is more and more considered, and that we will talk a little bit later. I want to take it separately. The principle of EGR is to redirect a fraction of exhaust gas into the engine. It reduces NOx produced during combustion. Exhaust, the challenges. Particles and soot can damage turbo and the engine. It reduces the efficiency of the intercooler. Particles need to be removed. Filter is the easiest solution to prevent from that problem. High temperature of exhaust can affect the efficiency, and we need a cooler to cool down the exhaust. In brief, of what we have said so far. NOx emissions can be reduced with the technology. You can see in the graphic, you can see the peak of pressure and temperature where the NOx develop. At this pressure, in the maximum compression and maximum temperature moment of the cycle, the nitrogen molecule that is very stable is a covalent triple link but at this pressure and temperature, it breaks down. It splits into atoms of nitrogen that combine with oxygen. That is what the engine manufacturers want to have to avoid, with a selective catalytic reduction and so on. As I told you, SOx emissions can be reduced by scrubbers. It means cleaning the air exhaust and the use of low sulfur fuels. One important point is that if we want to lower the CO2, we lower also the energy efficiency. It's kind of contradiction, but now the main priority, the top priority, is to reduce the CO2 and the NOx emissions. Just as an information, no? It's courtesy of Wärtsilä. Dual fuel engines are able to work on 2 cycles. Cycle Otto, it's an explosion engine, because the gas is needs the Otto cycle to work, and so you need to have a pilot diesel fuel that sparks the flame and burns the mixture of air and gas. Whereas when the engine uses liquid fuel, it works in the diesel cycle as usual. No spark is necessary. It's just the self ignition temperature achieved with a high pressure. Now we are going to talk about CO2 emissions. CO2 emissions, well, first of all, if we compare the marine industry, the shipping industry, with other industries, such as the airplanes or trucks, well, we can see that an oil tanker is 100 times more efficient in terms of grams CO2 per ton and kilometer. Is 100 times more efficient than a plane and 10 times more efficient than one truck. So it's important. Well, it's just for us to be happy, to be satisfied. But we know we can do something. We can go beyond these good figures. We have to reduce not only in comparison with others, but we have to do the best we can. That is why there are several regulations included also in the Annex 6 to Mark 4. IMO, the International Maritime Organization, developed a tool to measure and compare energy efficiency of ship designs. The EEDI, it is the Energy Efficiency Design Index. We will talk later about another index, this operational. It is the OI. Well, the comparison is not perfect, of course, because no consideration of seaworthiness and economy of scale of large ships, but it is usable, it's workable. It's progressively applicable to the majority of ship types. So far, it is not applicable to all kind of propulsion systems, let's say. The EEDI is mandatory for new ships. New ships whose building contract was placed after January 2013, so it's already in force, or delivered after 1st July 2015. So it is already in force. In addition to this index, there is a ECAMP mandatory for new and existing ships at first intermediate or renewal survey or after 1st of January 2013. So the ships are already provided with this ECMP. ECMP is energy efficiency monitoring plan. Well, the CO2 reduction by means of a design index. The EDI objective is to stimulate innovation and technical development in order to increase the energy efficiency from the design stage. Very important because the reduction in the consumption, in the fuel consumption, is much cheaper since the very beginning of the early design, let's say. The formula for the index, for the EDI, is a ratio between the environmental cost, it means the CO2 emissions at 75% of maximum continuous rating of the engine, plus fixed auxiliaries power. It's a ratio, as I told you, between this environmental cost and the benefit for the society. It means what's the benefit for the society? The cargo capacity for the ship speed. It means it depends on the what is the whereas the CO2 emissions are in grams CO2. The cargo capacity may be considered depends on the trade of the ship. The cargo capacity for a passenger vessel is the number of passengers transported. For a dry cargo ship or a tanker or a carrier, it's the tons or the weight carried. The ship speed is taken at 75% of the maximum continuous rating because it is fixed by the convention, by the Annex 6. The CO2 reduction to the energy recovery system is taken into account directly in the calculation. So all the measures prone to recovery, to energy recovery, are also considered. Auxiliary power calculation refers only to power for propulsion, machinery systems, and accommodation, not for other purposes. As I told you, the EDI is valid for ships with diesel, for diesel engines, not for diesel electric propulsion, or turbine propulsion, or hybrid propulsion systems that will be defined in later developments, in further developments of the Annex 6. The EDI of ships is to be calculated according to the IMO guidelines. There's an original document, some calculation, the formula. The formula is quite big, but it's very simple in fact, because it's the CO2 emissions divided by cargo capacity, no more. There are some coefficients and so on, but it's not. It's very intuitive. There are some curves for the ship to check that it is in compliance with the code. And the important thing is that there's a timeline in which the AVI has to be improved at the individual stage. So the designing this will be more and more required more demanding in the future. Shall I continue? Well, the certification of EDI, just a quick overview. If there is a preliminary experience with ISO 9000, so we check the EDI with computation or procedure to obtain the speed curves. Then we agree the test plan and check the SIP model and properly witness the key time test and issue a pre-verification report. But the final verification has to be carried out during the SIP trials program. Because you have to carry out a preliminary EEDI, but you have to verify the index during the SIP trials because it's part of the delivery of the SIP jet. And there will be a certificate. Some possible measures to improve the SEMP. Are quite varied and depend of the SIP type, but some actions may be weather routing, optimization. This is to improve to measure the energy used and to improve the energy efficiency, weather routing, optimization of the commercial speed, just-in-time arrival, slow steaming and super slow steaming that has been very used in the last years, not so often now with the low price of fuel. Optimization of ballast and trim, retrofitting of ESTs, we will talk a little bit later about it, and periodic hull and proper cleaning. Essential. The same, we talked about an index for the design at the design stage. The annexes are set up an index for the operation. It is the EEOI. The EEOI objective is to facilitate the quantitative monitoring of energy efficiency, and thus it may be used for the monitoring of the SEMP. The formula is roughly the same. Environmental cost, it means fuel consumption for CO2 conversion factor, divided by the benefit for the society. It means the cargo capacity times the distance. It's, as you can see, it's quite similar to the design index, but in this case, we use a fuel conversion factor for the CO2 consumption. From CO2 to fuel consumption. The capacity, cargo capacity, the same, depending on the trade. It is a simple, straightforward calculation. The AOI can be calculated for one trip or for a certain period, covering several trips, ballast ones included. So at the end, there will be an International Energy Efficiency Certificate on board the ship. It has to be placed on board the ship. The ship energy efficiency management plan is a tool for the ship owner to improve step by step and to reduce the fuel consumption. And as I told you, it's mandatory since 2013, and all the ship owners have to use it. Well, classification societies have developed the down classification notations, even when it is a statutory requirement, because it comes from the international convention. But classification societies have issued the classification notations for this purpose. The energy saving measures ranking, you have here a list, just help for you. You can see the capacity of each measure to save energy. For instance, super slow steaming is number one measure, the most powerful. But it's not always possible. You have other weather routing, just-in-time arrival, speed of optimization, trim, balance condition, and so on. And the important thing is you have to take all these measures together. And the big owners use some tool developed by themselves, by the classification societies or whatever, not only based on the machinery installations, not only that, but also the weather and current routing. It has to be uploaded in the systems. There are computer software. There's software. Veritas and other classification societies have a software to do it immediately, taking into account all kind of inputs, both from the technology, from the ship, and from the weather environment. So, the fuel oil consumption can be reduced by operational measures, improved maintenance measures, retrofitting energy-saving devices on hull, what we call ESDs. ESDs are based on hydrodynamics. Hydrodynamics in the propellers. And also calculating the gravitation and risks. And using the examples for evaluation of propeller performances, and also the evaluation of energy saving devices close to the propellers, such as nozzles and so on.
La mía también es central y nos la ponen en septiembre.
Of the CFDs in the propeller and the propulsion system, you have a CFD simulation for hull and appendages, including the propeller, of course. Outputs of the simulations are propulsive performances of the ship, evaluation of hull, propeller, appendages interactions, cavitation, sunset risk, pressure pulses, and examples of applications are hull power optimization, appendages alignment, twisted rudder, for instance, or shaft brackets, evaluation of several propellers performances. We will see some pictures later. Not only that, but also the trim optimization. You can see here some solutions. Some of them are more realistic than others, but for instance, you can see the Moorish duct, kind of collar around the shaft, and the air cushion. But this, well, you know, if the hull doesn't interact with water, the viscous resistance is less. Of course, you know, the resistance to the advance of the ship is the additions of the one due to the viscosity of water and the waves created by the ship. You can put some fins in front of the propeller. You can develop this kind of counter-rotative propeller, or loaded tip propeller with flange on the tip that increases it's proof that it increases the efficiency of the propeller, or you can use the twister rudder. But anyhow, you can do a tank test, of course, but the most simple estimation is the use of computer programs, CFDs. Also, in addition, you can set up in your company an ISO 50001 system for management of the energy that can be certified. Well, thank you very much. I finished my first presentation. Should you have any question, or if you want, I give you my email address. If you have any questions, please don't hesitate to send me a message or to ask. Okay. Well, shall I continue, or? Should I have another presentation? Because I want to talk about energy as fuel. We have a presentation for you because, well, the first presentation wants to explain you the regulatory framework. Means because the reduction of air pollution is not driven by cost or by money. Is driven by the regulatory framework that requires the reduction in air pollution. It has nothing to do with the costs. It's with the reduction, mandatory reduction, as we have said, that we have divided by 40 the SOx. We have reduced 80% the NOx along several areas. But it is driven by the regulatory framework, and that is what I explained to you in my first presentation. Now, I want to talk a little bit more about LNG as fuel. It is one of the solutions to comply with the code, with the Annex 6. Well, LNG is a workable alternative to liquid fuels, because NOx is reduced more than 80% compared with liquid fuels. It doesn't contain, it avoids LNG, it doesn't have SOx emissions because there is no sulfur in the natural gas, no particulate material matters, and also CO2 can be reduced by 25% depending on the technology. And with some, we have to be careful with the methane slip, because this methane is more harmful, let's say, than the same effect, greenhouse effect. But in brief, you have some advantages of this of LNG as fuel that we have to talk a little bit more. That is why I want to give you my policy about that. Compared to other fuels, LNG has a better energy efficiency, no residues, unlike the scrubbers. You remember that when I told you about scrubbers, there was some residues from after cleaning the exhaust gas, LNG reduces air pollution, and there is an additional advantage. There is less noise and vibrations in the diesel engines. Cons are LNG needs more storage, because 1 liter of LNG is equivalent to 0.6 liters of gas oil. And if you need for sailing in open seas, you need fuel oil, you need the kind of tanks. So you need more storage, more tank volume. The logistic of LNG is not available at some ports yet, but it is going to be solved at least in Europe and in the States and Canada. The crew needs to be trained and qualified. The return of investment, because the engines are more expensive and the installation is more expensive, because the pipes, the LNG piping has to be double wall and some requirements that make the installation more expensive than with conventional fuels, and there's not enough experience with the regulation. Regarding the LNG bunkering, of course, we want to have LNG fueled ships. We need LNG bunker ships in LNG bunker operation. We can say that LNG propulsion is very old. We know it. We have known it for over 50 years, and no significant accidents have been reported on gas-fueled ships. Now, the experience we have had so far with LNG as fuel is in the bigger methane carriers. They are very big ships, manned by very professional crews. Now, with small ships, there are new risks because of the diversity of size, type of ship, bunkering scenarios, and so on. So we have to develop the regulatory framework to keep the LNG shipping safety records, as we have had so far in LNG shipping. Guidelines and possibilities for LNG bunkering have been issued by all classification societies. All classification societies have issued its own rules, and there are several scenarios that have to be taken into account, depending on the type of bunkering facility and the type of receiving ship. In fact, the type of tank on board the receiving ship and the type of tank in the bunkering facility. Depending on in the bunkering facility, it is a bunker ship, or a tank truck, or a shore-based Type C tank. Type C means pressurized tank, usually cylindrical or bilobular or even globular. But so far, they are mostly cylindrical under pressure. And there can be also atmospheric tanks, either in the bunker ships or shore-based. Also, the receiving ship can be Type C tank or atmospheric tank. In this figure, you can see that the bunkering from a Type C tank barge to a Type C tank vessel. So since both are pressurized and the pressure is withstand by the vessel, it's not necessary to have a vapor return line. And the pressure equilibrium happens by equilibrium between the two pressures. In this case, we have a bunker transfer from Type C, bunker station or bunker ship, to atmospheric. So in this case, we need a vapor return line because the pressure may rise due to the cargo operation and the void off. The bunker is subject to the supply pressure and capacity to handle in the receiving tank. So the boil of gas may increase the pressure of the atmospheric one, that is the one admitted by the receiving tank. Sorry, by in this case the atmospheric the bunker barge is atmospheric pressure, and the receiving installation, the receiving tank, is Type C. In this case, is both are atmospheric tanks, so the control of the pressure and temperature of the gas is most important to prevent from the boil of gas to increase the pressure over the safety levels. And in this case, the tank truck is fitting the Type C tank on board the ship. It's well, the capacity of transfer of LNG is rather small, and is better for small yachts or for yachts, or for not for very big ships, because it takes hours to complete a bunker operation. In this case, there is a big LNG terminal to giving bunker to a Type C tank. In this case, the vapor return line is advisable. Sorry. LNG bunkering, general technical issues. There are some technical issues that we have to take into account, and that are in detail in the regulation, both either in the Bureau Veritas regulations or in other places. You have to consider compatibility of equipment between the supplier and the ship. Compatibility of equipment. Adequate compatible pressure and temperature and receiving tanks and bunkering rates as one energy, lower the content introduce gas while bunkering. Oil of gas is the liquid that becomes gas, the evaporated gas. Receiving tank with one LNG increases the bunkering pressure because of the boil of gas. It may be preferable in some cases to have the lowest energy temperature even for pressurized Type C tanks. Even when the Type C tanks withstand the pressure, but the pressure will increase with the tail, around the tail. It's better to have it as low temperature was possible because temperature and pressure are directly linked. Energy transfer by increasing pressure bunkering ship tank or by means of cryogenic transfer tanks. How do we fill the tank is a question. Do we need a return to bunkering ship or bunkering station, as we have seen in the previous sketches? Bunker rates require to be as high as possible in order to reduce the port operations. Could be hours in a tank-to-ship transfer operation of less than 100 cubic meters, but not more than 1 hour in a ship-to-ship operation. So the cargo transfer, the energy transfer from ship to ship is much faster than from a truck to ship. Limitations of the containment system, filling levels or pressures shall be taken into consideration. Possibility of rollover due to different densities of the fuel bunker and stored on board of the gas-fuel ship. The stratification of LNG with different densities, which might release a big amount of oil or gas. Means natural gas is has several fractions. It's not, and some fractions are more volatile than others. With the time, the LNG becomes aged. So the more aged, the more boil off. When we mix LNGs with different ages, they can stratify. But before stratifying, mix of barbons, let's say. And the movement of the barbons develops more boil of gas. It increases the pressure. It has to be. So one of the problems with LNG storage of ships is that it cannot wait. The storage cannot wait a long time without particular precaution. LNG, some additional operational issues, questions that will depend on the terminal, on the port terminal, on the port policy. Bunkering permitted while commercial operations are taking place. First, what happens in case of passenger ships? Ports with LNG and some others will not. In the beginning, all the precautions are necessary, but we have to go, if we compare, for instance, with commercial aviation, we board the airplanes while they are bunkering. Nothing new for us. Can there be simultaneous bunkering and loading operations? Fuel, oil, water, sludge? How to measure the LNG transport? Because the natural gas price is by energy content. You buy some calories, some power. Temperature and pressure of energy lead to different densities and energy contents. It's very important because the octane index of the energy may be different from, or depending on, and is different depending on the origin of the well. Required to have suitable methane composition to avoid misfiring in the engines. Is the composition of the LNG depends on the country where the well is placed. The behavior of the engines may be different, and there may be misfiring inside the engines. Well, the energy cooker depends, of course, the traffic situation in the port, emissions, but they have hazardous areas, daylight, only during the daylight hours, only during night. It depends on weather or not. So operational issues that have to be solved by, depending on the port authority policy. Safety means and precautions, simplicity and standardization of the working connections that is available because this is not a new industry. We have to avoid venting of gas or heating on board ships, before return to a bunkering ship, if possible, with couplings. Have to avoid leakages, of course, with dry brake couplings. We have to protect the surrounding areas with barriers to prevent from, not only for people, but also water curtains, stainless steel trays, and so on. We have to have a reliable system in materials, piping, valves, pumps, to operate with cryogenic liquid and prepare for a quick shutdown in emergency situation. Dry and breakaway couplings. It's very important that the main risk for the LNG is that it is cryogenic. It is 160 degrees below zero. The risk of fire exists, but it's not so. It's not the main threat. The main problem is the low temperature. There has to be an emergency shutdown, system interconnection, suitable communication with VHF. If VHF, of course, explode, adapted to the working gas, but it's normal in all gas operations. There may be anything process and equipment, depending on the design of the plant. People have to have their personal protection devices and specific training. There has to be a arrangement and safety means in the bunkering station, including protection against explosion following leakage. You know, the explosion may be caused by fire or by the contact with water, because as the liquefied natural gas is so cold, when it touches the water at normal temperature, it grows in size immediately, so it causes that explosion. So the contact with water causes explosions. And as always, when we don't have enough experience, because in this case we don't have enough experience in bunkering operations, because there have not been hundreds of millions of bunkering operations so far, we need to carry out a risk analysis. We will talk about it later. First, for bunkering ships, we need reliable and safe designs. There are rules for it. Classification societies have issued rules for it. There is a dedicated code from the International Maritime Organization. It is the IGF code. There has to be high loading rates and filling levels levels but safe bunker operation. There are some issues related with the area of operations: port, harbors, energy terminals, proximity to other ships, industrial infrastructure, or living areas. More severe consequences of potential venting and increased risk of collision. A very specific transfer system, but already available and reliable. Energy bunkering requires a specific equipment, of course, transfer arms or hoses or similar equipment, but it's available. Don't worry about that. Transfer equipment is to be covered by class when used on a routine basis. Boil-off management for LNG ships is a key issue, and it depends on the operational profile of the ship. The problem, ship waiting in port with no boil-off gas consumption in engines. What do we do with that? Because the boil-off is increasing, and it increases the pressure in the tank. So we have to do something. The extra boil-off generated, not only we have to take to bear in mind to specific conditions. One, ship waiting in port with no consumption, and extra boil-off gas generated during the bunkering operations, as I told you. What are the ways to control the pressure tanks? We may have a gas combustion unit, because if there is not a solution, we have to burn in a dedicated combustion unit. We have to burn the boil-off gas. Or we may have a boiler and use the boil-off gas to heat some other systems. We may have medical refrigeration or pressurized tanks. In this picture, we have there are prismatic tanks able to that they can withstand a small overpressure up to 0.7 bar. Whereas a independent Type C tank may withstand 4 bar or more. This is a very low one. Sorry. Boil-off gas management for LNG bunkering ships. As I told you, the LNG tank pressure and temperature control may be kept by the liquefaction units that keep the cargo cool and liquefy the boil-off gas. Well, it's one solution, but it's very liquefaction plants, liquefaction units are expensive. Very cool cargo means less extra boil-off gas during transfer and more energy content in the fuel transfer. On the contrary, high pressure or temperature lead to specific issues when bunkering atmospheric tanks because of the overpressure. But as I told you, venting must be avoided. And the area of venting necessary for emergency purposes is considered a dangerous zone. I will tell you. Well, there are quite a few experiences, so it's not rather new. The bunkering ships, LNG bunkering ships. We have a lot of references. More and more bunkering ships are under construction because, as I told you, the price is not the driver of the industry, but the environmental capacity of LNG to meet the requirements, to meet the lower, to reduce the NOx, SOx, and CO2. Here, just for your information, you can see several types of LNG tanks. In the left side, you have a membrane tank, and there's an independent type B tank, prismatic, and you have a tank rack or even a container vessel. Several membrane technologies for you to know. The membrane is made up of several layers with several isolation and insulation layers with paralytic materials and so on. In order to reduce the thermal coefficient of transmission of the walls, the bigger the coefficient, the better the coefficient of transmission, the smaller, the less heat comes into the LNG tank, and then the boil of gas is less. As I told you, the challenge for the LNG is the space for LNG storage on board, tank capacity, heating or refrigeration systems, segregation of species, because some species have to be segregated because they are hazardous areas. There has to be protection against leakages. Mostly because of the low temperature that can break the steel. If it is not stainless steel, it can make a hole immediately. In the arrangements for bunkering. As I told you before, in the cases where there is not enough experience, practical experience, the preferred technique is the risk assessment, whereby at the design stage for the operation, in this case, and also for the installation on board the ship, there are two risk assessments. One is for the operation, and another for the installation on board the ship. The tool used is the risk assessment. We count all the risks, we count the likelihood of happening, and the severity. So it's a normal risk assessment technique. Why a risk assessment for LNG bunkering? Not for the ship, but also for the bunkering. Because, for instance, if it is a spill in case of wind, the cloud may go out of the vessel and expand to other areas. And when there is an ignition source, there may be a burn. So, or the speed may enter in contact with water, and then we have the explosion. It was the case in Skikta in Algeria, where there was an explosion 7 years ago, and we have to prevent for these situations to happen. Regarding the bunkering station, the main concerns are ventilation, liquid prevention, and detection. The manifold must be able to avoid the connection hose to break in case of extreme relative motion or emergency. There has to be fire detection and extinction, as always we are in the presence of gas. we have, as operational constraints, we have to take into account relative motions, ship quay, and the G part, draft variations, depending on the type, mooring in different way, depending on the type, and also the cargo of the ship, mooring in different weather conditions, the meteorological data, ship data, but there are some software, some tools to help the ship operators to carry out these tasks safely. There are quite a few regulatory energy bunkering regulations, depending on the port authority and so on. There are also there are a lot of standards, not only for the ship. Standards are based on the IMO standards, the ITF code, and the classification rules from the classification societies, but there are also operational guidelines and rules from the port authorities and national authorities. The ITF code has been published recently and will enter into force next year, 2017. And it's applicable, this is 1st of January 2017. And at this moment is applicable to LNG as fuel. But it is expected the scope of application to be enlarged with other fuels, such as methanol or other fuels. Some containment systems, same is repeated fact. I apologize for it. Regarding the gas, the risks for the gas, there has to be a segregation. There's a segregation principle in the rules. It is you can see that it is the same principle that we have applied for decades with gas carriers in the safe area and the cargo area. The cargo area is in the tank area, and also the ventilations or the emergency ventilations for the gas. But for instance, in a passenger vessel, the hazardous area is not only the tank area, but also the machinery spaces, and also the vents at the upper deck, the ventilations at the upper deck, and the areas surrounding it. They have to comply with some requirements. In that location, the tanks have to be placed according at a certain distance from the ship site, in order to prevent problems in case of a collision, like the one in the picture. The distance, there are two methods. One is the deterministic method. It requires for passenger ships, the minimum distance is the breadth divided by 10 for passenger ships, another amount for cargo ships, and also a distance from the ship bottom in case of landing with an obstacle or something like that. And there is a probabilistic method. This instead of this is a sketch with the distances. You can see the B10s or the B5s, depending on B10s for the bottom, B5s for the sides, for the cow tanks, for the LNG tanks. But there is a probabilistic approach for according to the probabilistic method, using some criteria of probabilistic criteria. So if you don't, you as a designer, you have two choices. We have, as I told you, there are a lot of references of ships fueled by LNG with an excellent track record. Well, over 50 years. So we can trust this is one alternative to other fuel. LNG is a second alternative. It's a new system that has to be taken into account. It's valid for all kinds of ships, for instance, container vessels, very big container vessels, feeders, small feeders. There have been, and there are some conversions ongoing. For instance, in this case in Bergen, Viking. For instance, some owners have converted the generator sets to energy consumption because they have to be ports frequently, and there's a limitation of 0.1 sulfur emission. So it's interesting for them to use the generating power in energy. In sailing, when they are within a control area, they have to use the liquid marine gas oil or something like that. But at port, the main engine is not working. So, but the auxiliary engines work. They have converted in this case to energy generator sets. There are other, in this case, for instance, the Norwegian owner that has converted chemical tankers, oil chemical tankers, to dual fuel propulsion. With, in this case, normally Type C storage tanks are used. We will see a lot of them. In this case is in Canada, same problem, same solution, dual fuel propulsion, and also dual fuel generators, Type C tanks, and the deck, place on the decks. It's an inland navigation ship, a chemical tanker of West, another bunker barge. So there are quite a few references. And I think we are working at this moment with the conversion of passenger ferries. They are converting generator sets energy consumption at port, not in open seas, but at port. The generator sets are under conversion to LNG in some cases, of course. So Arias, there is another owner, is converting the car carriers and ferries to propulsion by LNG. There are several projects of LNG bunker ships. And also, well, the technology of engines is, well, main manufacturers are developing their designs. You know, there are two ways, two solutions. One is 4 strokes, another is 2 strokes. One, Brasilia, Royce, one has sound, and another fuel that is more and more considered is the ethane. Ethane, because there is a oversupply of ethane as an additional product of other processes, mid product, let's say. And there are already ships fueled by ethane and engines ready to burn ethane. Well, there are other examples, as you can see, you have seen, mostly with Type C cylindrical tanks. More examples. I'm going forward or backwards? No, it's okay. It's okay. There are other examples in Norway, Denmark, Canada, and you can see that it's more frequent in countries within sulfur or nitrogen emission control areas. But all the European ports, in fact, are control areas because the maximum sulfur is 0.1. For instance, one of the biggest references nowadays is the Tallink, this ship for 2,850 passengers and crew, under construction in Turku. But not only big ships, but also ships that have to work continuously at port and that have the limitation every day at port are developing technical solutions. For instance, this order for Ostenjo Ordereri, a Norwegian owner, that has placed an order for 3 tanks fueled by LNG with Viroitas class in Spain. And it's a very interesting solution because, you know, when a lot of cruise vessels come to a port, well, if they were connected to the town, to the city electrical network, well, it may collapse. So it's not a solution. Cold ironing is not a solution unless it is prepared, of course. And then these very big ships, the cruise ships, are throwing the air pollution from the generator sets, and they are polluting the air in the towns in very populated areas. That is why in Hamburg they have developed this very intelligent solution. It's kind of power station with LNG. So it's 5 gas fueled generator sets to produce electricity in Hamburg port to supply cruise vessels the municipal grid. So the cruise vessels, when they come into harbor, they can switch off their generator sets and they receive the power from this barge that burns energy. So another more projects, and that is why I wanted to tell you about LNG. LNG is very important and will play an important role in the fuel propulsion, in the marine propulsion. I would like to tell you something about the European ice switch from the change, because I'd like to tell you something about because it's related to emissions, that it's the main part of my presentation. Is the new European regulation MR. Excuse me, I did something wrong? Okay. Well, it's a regulation, European regulation. It's only in the European Union. The regulation is for the monitoring, reporting, and verification of carbon dioxide emissions from maritime transport. It's monitoring, reporting, and verification. It was adopted by the European Parliament this year and will enter into force immediately. The objective is the European Union strategy is to progressively integrate maritime emissions into the EU's policy for reducing its domestic greenhouse gas emissions. So, shipping is a part of the industry, of the pollution. It has to be included in the European regulations. MRV, Monitoring, Reporting, Verification Regulation, focuses on CO2 as it is the predominant greenhouse gas emission from ships. The strategy consists of 3 consecutive steps: monitoring, reporting and verification of CO2 emissions from large ships using European ports, greenhouse gas reduction targets for the maritime transport sector, further measures, including market-based measures in the medium to long term. The MRV regulation creates a framework for collecting and publishing verified annual data on CO2 emissions and energy efficiency from all large ships that use European ports, regardless of where the ships are registered. From January 2018 onwards, the true entered into force, CO2 emissions, energy efficiency will have to be monitored and reported by companies and verified by an independent verifier. A valid document of compliance issued by the verifier will have to be carried on board of ships subjected to MRV. There has to be a certificate or a document. The scope of the regulation, it applies to ships over 5,000 gross tonnage, with some exceptions, as we will see. It should be noted that ships below 5,000 gross tons are almost half of the fleet, but only 10% of the emissions. That is why they have been kept outside of the regulation, because they account only for 10% of the emissions. CO2 emissions are to be considered released by ships at sea during voyages from and to a port under the jurisdiction of a European state, or at berth with imports called under the jurisdiction of a member state. Method for monitoring CO2 emissions for each of the ships. Every company has to determine the CO2 emissions in accordance with one of the permitted methods permitted by regulation, and monitor all the relevant information. Monitoring is to be carried out on a per voyage basis and on an annual basis. So you have to do it twice. Per voyage basis and annual basis. How do we calculate the CO2 emissions? There is a fuel consumption. We know the fuel consumption, and we multiply it by an emission factor. The fuel consumption includes fuel consumed by main engines, auxiliary engines, gas turbines, boilers, and energy gas generators. Fuel consumption with import at berth is to be calculated separately. So you have the fuel consumption in main engines, and also fuel consumption at port has to be calculated separately. The emission factor is a factor for conversion for consumption, fuel consumption into CO2 emission. The default values are used in principle unless the company uses data on fuel quality from the bunker delivery note. There are some defect values unless you have a more precise ones. Determination of fuel consumption is for a ship and its voyage. The actual fuel consumption has to be calculated based on one of the following methods: bunker fuel delivery note and periodic stock takes of fuel tanks, bunker fuel tank monitoring on board, flow meters for applicable combustion processes, or direct CO2 emissions measurements. If this method is used, the fuel consumptions have to be calculated from the CO2 emissions and the relevant emission factors. Any combination of these methods is also acceptable, depending on the accuracy of the measurement. Monitoring is to be performed, as I told you, on a per voyage basis, except for ships performing a lot of voyages per year, or more than 300 voyages per year, on an annual, and always on an annual basis. The following data are to be collected, determined, and calculated: port of departure, port of arrival, date and hour of departure and arrival, distance traveled, amount of cargo carried, number of passengers, amount of cargo, distance, and so on, in order to calculate the index at the end. Values are determined by aggregation of the relevant per voyage data. The following parameters are to be monitored: amount and emission factor for each type of fuel consumed in total, total aggregated CO2 emitted, aggregated CO2 emissions from all voyages between ports and the member state jurisdiction, which departed from ports or to ports under a member state's jurisdiction. CO2 emissions which occurred within ports under a member state jurisdiction at berth. Total distance traveled, total time spent at sea, total transport work, average energy efficiency. The average energy efficiency is to be monitored by using at least 4 indicators: fuel consumption per distance, fuel consumption per transport work, CO2 emissions per distance, CO2 emissions per transport work. Monitoring. Okay. Reporting, first reporting amount of CO2, then monitor. We are talking about monitor. By August 2017, companies will have to submit to the verifiers a monitoring plan for each of their ships, indicated the methods chosen to monitor and report CO2 emissions and other relevant information, including in particular the procedures used for monitoring the fuel consumption of the ship, the emission factors used for each fuel, the procedures used for determining activity data per voyage, in particular the procedures, data sources, and formulae used for determining and decoding the distance, the cargo carried, and number of passengers as applicable, the time spent at sea between the port of departure and the port of arrival, the method to be used for closing data gaps in case of missing data. Companies will have to use standardized monitoring plans based on templates to be developed. They are not available yet. And then the report from 2019, every year, companies will have to submit to the Commission and to the flag state authorities a verified emissions report concerning the CO2 emissions and other relevant information. The emissions report should contain the following information: company data, identify the verifier that assessed the emissions report, information of the monitoring method used and the related level of uncertainty, results from annual monitoring of the parameters. Well, this is an explanation of what I don't think it is necessary. You are tired. I've been speaking for a long time, and it's self-explanatory. The important thing is to know that it entered into force this year. During next year, shipowners have to prepare the technical files, and in 2 years' time, the verifiers will be accredited, and the monitoring plans have to be submitted to be verified by the shipowner. In 2018, the per voyage monitoring begins, and in 2019 and subsequent years, every 30th of April, the report has to be submitted to the Commission and flag authorities. In June, the document of compliance has to be issued by the verifier, has to be available, and also the Commission will make publicly available the information of CO2 emissions, fuel consumption, technical efficiency of the ship, and so on. This is the timeline. The same I told you in words. That's it. I don't know if you have any question. If you don't have any questions, you have my email address, and you can send me all your questions. I will do my best to answer you as soon as possible. Thank you very much for your attention, and I keep at your service. Thank you very much. Finish.